In this chapter, we will be taking a closer look at functions in Python. Up until now, almost all of the code we've written has been contained in a single file and executed in a top-to-bottom approach, with only minor changes to this program flow caused by conditional statements and loops. And while this may be acceptable for very short scripts, when you start writing larger programs, this approach becomes cluttered, difficult to read unless you add a lot of extra comments, and inefficient due to a lack of code reuse. You will be spending a lot of extra time rewriting the same code blocks over and over. So this is where functions come in. Functions provide the ability to create reusable code blocks that can be called from anywhere within your script. This allows for a high degree of code reuse. You only need to write a function once, and increased modularity. The Maya commands module is a good example of this. It contains most of the mel functions found in Maya, all in one spot. When using functions as a means of code reuse, you not only save yourself from having to retype or cut and paste code, both of which can be highly error-prone. It also allows you to update these code blocks in a single place inside of the function. And this change will be automatically picked up anywhere that function is called. If you were to rewrite these blocks of code each time they happened in your code, instead of using a function, anytime you made a change to that block of code, you would need to go through your scripts and update each location where it exists. And once again, this is error-prone, and it can lead to a lot of bugs in your code. On screen, I have an example that demonstrates functions. So this script contains two functions. Each of them starts with the def keyword, followed by the function name. So the first one is create car, and the second one is create tire. And when I call this function, I'm just going to call this on the first car, and I execute the code. Inside of Maya, this is creating a plane with 4 cylinders that make up a very basic car. And then this is all grouped together, as you can see, inside of the outliner. To compare this with similar code, I've also created a short script that does the exact same thing, but without functions. And in its current state, you can see it's about the same length as our functions example. So I'm just going to split this into 2 views. I'll just maximize this a little so you can see them side by side. And what's happening in the script with no functions is that it first creates the body, followed by 4 tires, and it then groups them together. And if I delete my existing car, let's just delete the car group, and I run the code with no functions, you can see that the exact same car has been created. Now, while in their current state, both of these scripts, the one with no functions and the one that contains functions, are approximately the same length. However, if I want to create more than one car using the no function approach, I essentially have to copy my code, all of it, and then paste it again below. And if I want to position the car at a different location, I have to update its translate value. So now if I first clear out my scene and rerun the code with no functions, I now get 2 cars inside of my viewport. All of a sudden though, my code with no functions is twice as long. And if I want to create a 3rd car, it will become 3 times as long. This isn't the case when I'm using functions. So jumping back into my functions example, once I've written the function to create the car and to create the tires once, I can call them as often as I'd like without having to rewrite the code. So down at the bottom, you can see that I'm creating 4 different cars, each at a different position. And once again, if I remove the cars in my existing scene and rerun the function example, I now have 4 cars displayed in my viewport. And this only required 1 extra line for each car. So here I have car 2, and I'm just passing in its position, car 3 and its position, and finally car 4. Now you may be saying to yourself, well, I can just wrap the creation of the cars inside of a loop. So if I want 4 cars, well, I can create a for loop in the range of 0 to 4. And this will give me 4 cars. But you still have to be able to set the positions inside your loop. So yes, you could create a list of positions for each of those cars. And this will allow you to minimize the amount of code, but you are starting to up the complexity. So for example, if I just delete the second car that we've created, if I'd like, I can create a loop. So for I in range, and this will be 0 to 4 if I want 4 cars. And I just have to make sure to indent to keep everything in the for block. But now I need a way to change the translates. And as I said, I could create a list, which contains a list or a tuple of positions, and then index the list to determine which position I should be using for each iteration in the loop. But even just trying to explain this gets complicated. And then what if I want to change one of the properties of my tire, for example? So currently the scale is being set to 0.7, 0.7, and 0.275. When I'm using functions, I can change these values in one place. So I can go to 0.75 for x and y if I like. Jumping back into the no functions example, I need to do this in 4 locations, once for each tire. Once again, you're starting to introduce the possibility of errors in your code, and this is something you should avoid at all costs. Additionally, with functions, I can add extra arguments. In this case, I could add scale x, scale y, and scale z, and allow the user to provide the scale for each tire. I don't have this option when I'm working without functions. Another benefit of working with functions is that I can provide default values. So here I've added scale x, y, and z. And if I want to make these optional values for a user when calling a function, I can provide defaults now. So here I can do 0.75, 0.75, and 0.275. And then I can replace the hard-coded values inside of the function itself. So I can just replace it with the variables or arguments scale x, scale y, and scale z. So once again, by using functions, I'm able to add an extra level of control and flexibility to my scripts. Now in this lesson, I've largely glossed over the syntax and how to create your own functions. And that's what we'll be looking at in the remaining lessons in this chapter.